Hello everyone. So in this video, I am going to discuss these two questions from integration, what I encountered last week during my class teaching. I found that the students are struggling in the very first step how to approach. They come up with various type of solutions, but in this video, I aim to provide a neat and clear approach to think how we can manipulate the integrand and go deeper in the techniques of the integration what we are going to apply to find the integral. So the first question is x squared plus n into n minus 1 divided by x sin x plus n cos x the whole square. The J main questions what we have seen in the recent years, they know such limitations and they know such bound in the techniques and all. And the manipulations or the calculations, even if you know how to apply the techniques or the substitution or the integration by parts or anything, it leads us to a very long calculation. So in this scenario, we should learn how to think smartly sometimes. So these are two questions of such type in which we can think smartly and get the answer quickly. So this question you may have encountered before also if you are preparing for the J main. It is almost everywhere. So I have this x squared plus n into n minus 1 on the top, and the denominator I have x sin x plus n cos x the whole square. So one popular or usual technique we have to manipulate the integrand is to multiply by x to the power 2 n minus 2 and proceed it. But let us think in a different way. What is a different way to think? Is that we know that the x sin x plus n cos x, I can treat it as the a sin x plus b cos x. And you know, this can be written as a square plus b square root, and this I can write sine of x plus some angle, let's say theta, where I can say that the theta I am using here, and I'm calling a by square root of a square plus b square as cos theta. Then only it will be constructed sine x plus theta. So I'm calling the base as a and the perpendicular is b and the hypotenuse is square root of a square plus b square. So you can know how to do it. Now in the same way, I'm thinking x is as the place value of a and the n is the place value of b, and writing this thing as square root of x square plus n square, and here sine of x plus theta. But in this process, I have to understand that the theta is not a constant here, because theta depends on x and x is a variable here. So I have to be very careful. So I will just write a side note here. The tan theta we are taking, because I'm taking x in the denominator, so then only it will get x by square root of x square plus n square, and it will lead us to a cos theta. Therefore tan theta is nothing but, because this time a is x and b is n, so I can write n by x. So this thing we have to keep in mind. Now what we'll do is that, let me just take this thing down. After this, you can think that if we are assuming this sine of x plus theta as t, or let's say x plus theta as t, what will happen? By the way, there is a square here, we have to be careful. So I'm assuming t is equal to x plus theta. So that cleanly I can use the tan theta as n by x. So that is going to give us t is equal to x plus tan inverse n by x. Now let's differentiate it. So dt by dx is 1 plus 1 by 1 plus n square by x square. And with the chain rule, I have to differentiate one more time that argument n by x. So that'll give you minus n by x square. You notice what will happen after this, that this is going to give us 1 plus x squared by x squared plus n squared into minus n by x squared, where x squared and x squared get cancelled. And from here I can again take the LCM and combine the whole ratios, two ratios in one. It will give you what? X squared plus n squared and x squared plus n squared minus n. You notice one thing. I have x squared plus n squared divided by n minus 1 is on the top. So we are getting something like this. But before that, we have to write this x sine x plus n cos x in that format. So when you write, what we get? This will give us, let me write it here. This x plus sine x plus n cos x as square root of this quantity, means the square root of x squared plus n squared into sine of x plus theta. So what I get? I get in denominator that x squared plus n squared without the root because I'm taking a square. And here I get sine squared n plus theta dx, and that is x squared plus n into n minus 1. You notice one thing, as soon as I took x plus theta as t, our dt by dx became this one, this quantity. It means the dx value is nothing but the reciprocal of this into dt. So I can see, or I can say this thing also, this overall quantity is dt. It means I'm getting 1 by sine square t into dt. And 1 by sine square t is nothing but cosec square t dt. I'll have the integral. And then it'll get you negative of cot t plus c. And you know, after that I can substitute the value of t from there. So that will give you minus of cot t was x plus theta and theta was tan inverse x. Or you can write this thing as the cot x plus theta formula, that is give us cot x cot theta minus 1 divided by cot x plus cot theta. And from there I have cot theta is equal to, because tan theta I have taken n by x, so cot theta will be x by n, and we substitute every cot theta what we see in the numerator and denominator with this tan of x by n, and cot x is just cot x. We can, if you like, you can write it as tan x, and we get the answer. So this is one clear approach without going into the long calculation approach where we multiply this ratio with x to the power n 2n minus 2 and divide by the same quantity, and then we manipulate that thing. This is the first question. By the way, I will be not surprised if the JEE Main someday will ask this kind of question. The level of the questions the JEE Main are setting these days, no wonder they will ask you this question. Suppose you have x squared and this is, let's say, 72, and they will give you here x sine x plus 9 cos x and the whole square. So you notice there, if you have this experience of solving this question, you can see the n is replaced by a number 9. And so the top has got x squared plus n into n minus 1, that is x squared plus 9 into 8, that's 72. So you know the process will be the same. And I'm not encouraging you to remember the final integral, but to understand how the thinking is developed. Let's go to the second question. In the second question, I have x squared sine 2x minus sine 2x, and with x tan x minus 1, and so on. So try to observe carefully there. We have x squared sine 2x and sine 2x here. It means that both of the terms have sine 2x in common. So what I'll take first, I'll take x squared sine 2x, and I'm multiplying this thing minus x sine 2x tan x. And this will give you plus sine 2x. And in denominator, I have x squared plus 1, the whole square dx. Now notice, if you have experience of solving the JEE mains level question, or you may have encountered this kind of questions often, that in some questions what we do, we keep the first integrand, apply the integration by parts, but the second integrand or integral, we don't integrate it in the hope of the first we integrate in this process, something will come in the form of integral that will cancel the second what we have saved. So the whole thing we have to think in that way. So here the same thing is going to be done. You notice this, from these two terms I'm taking sine 2x common. So if I take sine 2x common, I will get 1 plus x squared, and the remaining thing I'm writing x sine 2x tan x, and I'm separating the denominator with it. Now you may have the doubt that why we are doing so, because you notice if I take in this way, this 1 plus x square, one factor will cancel this, and we may hope that if I take the sine 2x by 1 plus x square and apply the integration by parts, in the process this 1 plus x square the whole square will come when we differentiate the 1 by 1 plus x square, because the denominator will get higher power when I have the differentiation of any denominator only, means 1 by x kind of a structure. So if I cancel this thing, I will get the first integrand as sine 2x by 1 plus x square. And here I'm keeping this thing as it is, and sine 2x into tan x will become sine square x. 2 sine x cos x, so it will become 2 here also. And divided by 1 plus x square, the whole square. Now, a little bit clarity we get here now. Once again, I'm saying that sine 2x by 1 plus x square, I'm taking it two separate functions and I'm applying the integration by parts in hope of that in that integration by part, some term in the form of integration will come only that will cancel this thing. So let's hope for a good, and then we try. So I'm keeping this thing as it is. I'm not going to disturb this thing. And here I'm applying integration by parts by using 1 plus 1 by x square as the first term and the sine 2x as the second term. So we get this thing, and I let you already know that is going to be that, and negative 1 by 1 plus x square the whole square, into 2x, and again the integration of sine 2x into dx and the whole dx. And this guy I'm calling it, let's say I1, and minus sign, please understand I'm not using it, so I'm writing minus I1. Okay, now what we get here is the integration of 1 plus x square and sine 2x will give you integration, that is minus cos 2x by 2. This minus and this minus will become plus, sine will become plus, and this is 2x by 1 plus x squared the whole square, and is again minus cos 2x by 2, and again dx, and of course it's a minus y. Now the problem is, how do we get the exact integration back? Or because you see the options, we don't have any such options like this, so we have to deal with this situation as well. So what we do now, I'm keeping this thing as it is, 1 by 1 plus x squared minus cos 2x by 2, and here we have cos 2x by 2 and so on. So the trick is that we are applying this formula of cos 2x in form of sine. So I'm taking this minus out and I'm writing there 2x by 1 plus x squared the whole square as, and this cos 2x I'm writing 1 minus 2 sine square x dx, and is minus 1. Now you can see what is that, and there's a 1 by, there's a 2 also here, so 2 and 2 will get cancelled, and I'm separating this thing as minus cos 2x by 2 1 plus x squared as it is, and here I have this 2 integrations. There's a 1 by, rather x by 1 plus x squared dx, and plus 2x sine square x by 1 plus x squared the whole square, and that minus 1 was already there. You notice these two will get cancelled because the same thing we have. They're the same quantity as I1, you can identify, and there's a plus sign, there's a minus sign, so this is nothing but I1 I have, so these two will get cancelled. So now we have this thing to handle, and you notice if I take any of these options, like in terms of cos 2x, there is no such thing, because with cos 2x I'm getting something extra as well. So first of all I have to integrate this thing. It's an integrable, so that is going to be minus cos 2x divided by 2 times 1 plus x squared, and here there's a 1 by 2, and that is going to be directly 1 by the way, there is a one mistake I've done, this is x squared should be there, so that is going to be, if I take this 1 plus x squared is t there, the derivative is already there, so I mean to say this quantity will become half of minus 1 by 1 plus x squared. Okay, so it will give you minus cos 2x 2 1 plus x squared and plus 1 by 2 1 plus x squared. You notice there are other options also in terms of sine square x. So we hope that the cos 2x will not work, because with cos 2x I have some extra terms. So maybe sine square x will work. So I'm again converting this cos 2x in form of sine square x. That will give you 2 sine square x minus 1, because I'm using this minus sign as well. 2 1 plus x square and plus 1 by 2 1 plus x square. So you notice we got the answer, because when we separate it, that will give you sine square x by 1 plus x square and minus 1 by 2 1 plus x square, and here also with a plus sign, same quantity. So we get this to cancel, and we get sine square x by 1 plus x square plus c as our answer. By the way, in all of them, the c we have to use doesn't mean the c is not given. Okay, so we got that the answer A is correct. So this was the approach done by the students, but we can think better. These are lengthy calculations, but how do we think better? Let me start from here. We notice these two I'm taking. So up to here, I have to do the same process for this question. And for your reference, let me again copy the question back so that you can understand the scenario. I have this thing, and if you separate it, I will get the two integrations like this. Now, my point is why we do so long. Let's try this way. We know the process is the same. I have to apply the integration by parts here. So I'm taking 1 by 1 plus x squared at the first, and I have to integrate sine 2x. And again, minus sign, and the same thing I have to do. Derivative of this is going to be minus 2x divided by 1 plus x squared the whole square, and then the integration of sine 2x dx. And here there is a minus sign with I1. And this minus will become plus. Now see, what I'm thinking is that the idea is very simple. When you want to integrate something, it means you are looking for such function whose derivative is sine 2x in this scenario. So I'm looking for a function whose derivative is sine 2x. So we got as minus cos 2x by 2. But you also notice that if you differentiate sine square x, you also get the same derivative. It means I can tell that the integration of sine 2x here is sine square x as well. So 1 by 1 plus x square, and here I can write sine square x. And as soon as you apply the same thing here, you notice this minus will become plus, and it will become sine square x, and 1 plus x square. It will be the same integration what I left for the cancellation. This will cancel, and we got the answer in one step. So this is the way we should apply sometimes with thinking out of box, and it's not like it will come immediately. We have to struggle and think deeply. The similar kind of thing we can do in this kind of question. Suppose you are integrating x tan inverse x. So I have tan inverse x and the integration of x. And here, derivative of tan inverse x is 1 by 1 plus x squared dx. Sorry, not dx. The integration of x dx and the whole dx. Now the aim is to find out here the integration of x. But you know this is x squared by 2. But we can also do better, because here you write x squared by 2. Again, you have to manipulate everything. Once you write x squared by 2 here, I have one more time to integrate. How can we think better to just not proceed to the further integration? So we think that I need such function whose derivative is x. So what I'm going to do is, at this whole thing I'm writing, I'm identifying a function whose derivative is x as half of x squared plus 1. And why I'm doing so? Because once I write this whole integration as half of x squared plus 1, I can cancel this x squared plus 1 directly. And so I don't have a further big integration. And when I identify the same thing is acting here, the same function I will act here. So they'll give you what? Tan inverse. And this is going to be half of x squared plus 1. And this quantity is just half left out, so it'll give you minus half x. And you go by the similar process, you get the same answer. It's not similar process. I mean to say, you go by the natural process of the integration by parts, you get the same answer. So that is it for this video. I hope you learned new things. For video like this, or if you want me to go deep dive into the other integrals techniques and all, or such questions, please comment and stay math active. Thank you.